one of the systems we're using for predictive maintenance. And then later on I will hand over to my colleague Joachim, who is on a weekly basis speaking and working with customers on how to use the system. And Joachim will share some of the reasons and ways the customers are using our system in their daily operation and their successes. So I'm going to start with a question. How many in this room are doing regular health checks? You don't have to answer, but I can imagine that many of you are, but I see myself as one of them that is not doing it regularly. So, what is the reason why we're not doing it regularly? There are many reasons, but one of them is certainly that we see ourselves in being in good condition and health. Or, even worse, we're afraid of what can be found. No matter what the reason, wouldn't it be good to have early indications of something that can get worse, but be avoided if treated early? Imagine you were the coach of a football team. How do you select the specific lineup to enter the pitch for the game this evening? Well, for a top team, you would certainly have loads of general health data. You would also know the general condition of the players, but in the end, you select the final lineup based on the capability and the daily shape of the players. Bromma has developed a concept and an algorithm for spreader health. The idea originates from the gaming industry, in which the health of the players in the game is measured by how well they perform in the virtual world. In our case, based on an internal analysis of such things as sensors, sensor signal stability, motor power consumption, and general faults we see on the spreader, combined with how many moves are being done, we have developed and invented an algorithm for spreader health. Spreader health will enable the terminal operators to select their first lineup to start the day, and also give important information when to repair or replace individual spreaders to avoid costly interruptions. SMS will give early indications of issues that may become worse and cause problems in the end. So by using and listening to it, being predictive, you can avoid issues becoming problems that will cause downtime. You will be able to plan and do the necessary maintenance during planned downtime in order to avoid troubles when you're doing loading and unloading operations. This is the only screenshot you will see today, and it will characterize sort of how this is done. On the screens you see general color indicated health data, and when you see something going from green to yellow, or even worse to red, you can drill down into that individual spreader, into that individual machine, finding out what is causing the problems. But not only that, once that is done, you will also get to the level where you are getting information and IDs, instructions how to solve the problem. The obvious thing here is to help you fix problems quicker. 60 years of experience could be referring to how long Bromma have been supplying spreaders, but that's not the case in this case. 60 years of experience is roughly the amount of collected experience that we have built into SMS. During the development period, we more or less locked in a group of our most senior service engineers, together with R&D engineers, to identify what are the patterns that in the end leads to problems. And then also, when you have identified what these patterns are, to find out what to do if this happens. Today, we have over 50 terminals that are using SMS around the world. A good indication of their appreciation for the system is that up until now, not a single terminal who have started to use SMS have opted out. Everyone is still using the system, and Joachim will very shortly share some of the reasons and the functionality that they are using and experiencing. So with that, I'd like to hand over to my colleague, Joachim.
Let's see if you can hear me. Yes, I think you can. So I will now move on. Now you've heard a little bit about the technicalities and the background of this solution we have. But end of the day, it's all about condition-based maintenance and ways for terminals to increase productivity and have a more stable equipment out there. One of the examples we picked up early on in the process is actually one of the early adopter customers who came in. They had this practice, or this guy had this practice. We're now in the south part of Europe, a pretty big terminal. When he came in, this man is responsible for the maintenance execution. When he came in the mornings, he jumped in the car, drove around the terminal, talked to all the crane drivers, trying to get some feedback of, okay, is there any problems out there? Is there anything we need to attend to? Within just a few weeks of having the system in place, he changed behavior completely. So now when he came into the office in the morning, he sat down in front of his computer, and off the screen, he got instant feedback of exactly what was going on. Do we have any problems out there? Is there anything we need to address? And he was telling us that he now had faster information, better information to make more informed decisions of the daily operations and the maintenance plan. One of the other customers in the same region, they actually decided to put the system on a big touchscreen in the maintenance operations room. So in there, they now have the whole team having immediate access to the data and the information. So they, as soon as they approach a spreader to do some maintenance, do some activities, they know, okay, is there anything additional going on here I need to know? Is there any sort of problems building up? Because that's very much the case. You see these problems, when you look at the data, you see the problems building up. When you look at the spreader, you usually only see the problems after it's a little bit too late. So they now have this insight, and it helps them to be more efficient. That we're clicking. Then moving from the condition-based, there is also the other use cases. So also for the scheduled maintenance, the maintenance you do on a clock, you still need some data, you need some input. So this can be quite tedious, and just over the past couple of weeks I've been speaking to customers in Australia, in Africa, in Europe about the same issue. That they, in the way they are set up, they need to go out to each spreader, they go out, get the spreader down, they note down the readings for the moves, the running hours, then they move on to the next one. And so it's a time-consuming, tedious process to get the basic data that they can then go back in and hopefully correctly and accurately manually input into their asset management systems. As soon as they get SMS in place, they have this data at their fingertips, they have it on their screens. They can either copy-paste, they can download a file, and we also have a couple of customers who have chosen to do a small investment in an IT integration and now have the data seamlessly flowing from the spreaders all the way through into the asset management system, and they then have a fully automated planning process. That we can take the next. There are also those kind of use cases that you do not, well, the things we haven't anticipated, the things we didn't see when we started. I was talking to one of our customers in the Americas, again a very large terminal, a lot of spreaders, a lot of equipment, and they have gotten into a new practice now. So in the unfortunate cases when they have a spreader stuck in a ship zone, this is a problematic situation. It's an interruption in the productivity. It's an potentially unsafe situation. The common practice they've been using up until now, the only way to know, well, you can talk with the crane driver, you hopefully can get some insights in what's going on down there, but ultimately you need to send somebody climbing down, investigating the situation, doing the analysis, worst case climbing up, getting the gear, climbing down, fixing the problem, and then off you go. Now instead they stand at the quayside, they look at their telephone, they can immediately then get the problem diagnosed. Ultimately they still need to probably go down that chip cell, but now they know where to go, what to do to resolve the issue. So this has been both a time saver, but also reducing some potentially hazardous activities, you can say. The final sets of examples I have, and those are relating here not to the spreaders. The spreader monitoring system obviously is a system about spreaders. But we also have a couple of cases where the system has been instrumental in resolving issues on the cranes. We have this, it's funny because I had a discussion with a customer here yesterday at TOC. They have exact the same situation. But this example is about a customer in the north part of Europe. Again, a large terminal, a lot of spreaders, a lot of cranes. High-performing operation, but they have the unfortunate situation that on a few of those cranes, quite a few of the cranes, they have, well, I don't know how to say, dirty electricity. So they have problems with the spreader crane cam communication. This is a tricky problem. It's hard to diagnose. It's hard to resolve. But with SMS, they have now been able to, in the first step, ultimately finally pinpoint which of the cranes have the worst communication issues. And then in the next step, working together with us, so Bromma and the terminal guys together, we've been able to trial different methods of resolving the problem. So grounding a little bit here, replacing some cables over here, applying filters, applying boosters. Ultimately now they have found a working solution that then can be proven in the system that yes, now we have a clear communication. Based on that, they have now decided to move ahead. So they are now rolling out this fix crane by crane, and hopefully pretty soon they're going to have clean communication, no interruptions, and then none of these safety concerns either. There is a related example, also my last example. We had, again now down in the Mediterranean area, we had one of the early adopters coming into the system. When we started it up, things were going well. We found some issues, we helped jointly to fix them. But then we found this one peculiar operational issue that when they do certain twin moves, they get an interruption, there is a stop in the process, there is a time delay. And again, one of those things, very hard to notice without the data. With the data, it becomes very evident, very transparent. So they, together with us, we jointly analyzed, investigated, and found out that there was a logic issue in the crane program. And by resolving this one, we were ultimately able to help them to shave off more than 100 hours of operational downtime, you could say, over an annual basis. So another happy example. And ultimately, if we go to the last one, so from all these examples, the common denominator is of course the customer. The customer and the customer feedback for us is instrumental in the whole design process. When we went into developing the first generation of the tool, we were conducting interviews with customers all around the world. We were showing prototypes, we were getting feedback, we were getting ideas. And this helped us developing the first generation of the solution. And since then, I tried to personally talk to as many of the different users and the customers as I can, because it's in this interaction that I can hear about the real issues, the real problems, and get those ideas of what are the next steps. Because a solution like this, in my opinion, it's never ready. It's something you continuously develop and develop. I hope you found this interesting. So if you want to hear more, please come and join us at our booth.
Thank you, Lars and Joachim. I think we'll take questions at the end. We are the last session, so we can have as many questions as you have at the end, but we will move through the presentations